Let's look at the solution of modern maths bites. In a group, there are 32 people. All of them know at least one of the three languages, Hindi, English, and Marathi. 25 people know Hindi, 20 know English, and 15 know Marathi. Okay. Let us record that. 3 sets. 25 know Hindi, 20 know English, and 15 know Marathi. 15 people know Hindi and English. So 15 here. And 5 people know English and Marathi. So 5 people here. If 3 people know all the 3 languages. Okay. So if this is 3, this will be 12. This will be 2. So I have 15 plus 2. So this will be 3. People who know only English will be 3. Now see, total count of people is supposed to be 32. Total count of people is supposed to be 32. 20 of them are already within the English circle. So if I take this as A, the people who only know Hindi will be 25 minus 15, 10 left for these two groups. So this will be 10 minus A. And people who only know Marathi will be 15 minus 5, also 10 minus A. These three groups together should add up to 12. Or 20 minus A should be equal to 12, or A should be equal to 8. So this is 8, this is 2, this is 2, all conditions are met. Finally, the question is then how many people know Hindi and Marathi? Hindi and Marathi are both these regions. Answer to the question should be 11. Hopefully nobody marked the answer as 8. Next question, 50 green balls, 50 blue balls, and 50 yellow balls are kept together in a large basket. Some students picked all the balls in the basket, where it was noted that none of them picked more than one ball of the same color. The number of students picking up only green balls is 10 more than the number of students picking up only yellow balls. Okay, so we have to make circles again. Okay, I have 50 people in green, I have 50 people in blue, and I have 50 people in yellow. Okay. The number of students picking up only green balls is 10 more than the number of students picking up only yellow balls. Okay, so if yellow is x, green is x plus 10. Okay. Of the students who picked up a blue ball, exactly 20 picked up at least one more ball. So these three regions here add up to 20. Given that blue entirely is 50, this is 30. This region here is 30. Additionally, we are told the total number of balls with the students having the blue ball is 74. Now only look at the circle for blue. These people have one ball each. These people who are marked with A have 2 balls each. And these people here have 3 balls each. So 2A plus 3B should be equal to 74 minus 30 should be equal to 44. Should be equal to 44. And we also know, acha, how I'm saying 2A plus 3B, let me write it as 4A. I can't take same variable, no? Wait. People who like exactly 2 balls, they are cross and I'm referring to them as A. And 2A plus 3B is 44. And I also know A plus B is equal to 20. So if I double this up, I know 2A plus 2B is equal to 40 or B is equal to 4. We know there are 4 people here. And these two cross regions will add up to 16. Now the critical part of decision making comes into play. See, final question is, what is the minimum possible number of students? I want to minimize the number of students. If I want to minimize the number of students, I want maximum count of people to go here. I want maximum count of people to go in the overlap region of green and yellow. How do I ensure the maximum count of people goes there? See this. These two groups and these two groups, if they were equal, if these two groups and these two groups were equal, then everybody else who is left can be pushed into this bracket. then everybody else who is pushed is left can be pushed into the group that only takes green or only takes yellow. These two groups here, I'm referred to them as cross, or if you want, you can do it in the form of a dabba. These two groups add up to 16, but I also want to ensure that 10 more people come within yellow. How I will distribute is, I will put 13 here and I will put 3 here. So now both of them have 16. Additionally, the number of people in green who are not overlapping with yellow and the number of people in yellow who are not overlapping with green, they are both x plus 13, x plus 13. So now x plus 13 plus 4, 37, 13 plus 4, 17 people are taken care of. You can happily put 33 here. You will have 0 people here. You will have 10 people here, and all conditions will be fulfilled. You have basically minimized x. Okay, so now what will be the count of people here? Can you see green total is 50? And then you have 2 extra numbers, a 30 and a 13. You add them up, you will reach your answer 93. Next question. 3 distinct numbers are randomly selected from the first 20 natural numbers. Find the probability that the selected numbers are in geometric progression having a common ratio greater than 1. Okay. First, let's look at the sample case. Sample space is going to be 20C3, which is equal to 20 into 19 into 18 by 6. So cancel 3. So 57 into 20 is 1140. The denominator is 1140. Now let's list out all possible geometric progressions. When the common ratio is 2, I can have 124, 248, 36, 12, 48, 16, and 5, 10, 20. I get 5 series from here. When the common ratio is 3, I can have 139 and 2, 6, 18, but I can't have any more. When the common ratio is 4, I can have 1, 4, 16, and then 5 and 2 and 1, 8 cases I've already got. Sadly, I'm guessing a lot of people would have ended up choosing the answer here right away. See, the condition that you're missing out on is the fact that nobody said that the common ratio has to be integral. Common ratio could very well be fractional. For instance, if the common ratio was 3 by 2, can we have this 4, 6, and 9, and correspondingly 8, 12, and 18? We get 2 more series from here. And we could also have common ratio as 4 by 3, wherein you will have 9, 12, and 16. How do you identify which common ratios would work? Basically, if you see the movement here, you're moving from one perfect square to another perfect square. One perfect square to another perfect square. After you've moved from one perfect square to another perfect square, you simply look at its multiples. Can it be possible? If we went up till 30, let's say we went up till 30, you could also have another series where the common ratio is 5 by 4, and you would have 16, 20, and 25. This would also be a common ratio. This would also be a series that is acceptable. Just that because we are only going up till first 20 natural numbers, we don't have to count this. We get 11 cases in total. This was the sample space. The answer has to be option B, 11 by 1140. Next question. Half of a class of 200 students enrolled for exactly one of the 3 activities: swimming, skating, and dancing. Total enrollments were 80, 75, and 60 in dancing from the class. Okay. So I now know A plus 2B plus 3C is equal to 80 plus 60, 215. Additionally, A plus B plus C plus D is equal to 200. Now see what these equations mean. A is the count of people who take up exactly one activity. B is the count of people who take up exactly 2 activities. C is the count of people who take up exactly 3 activities. And D is the count of people who take up no activity at all. Who take up no activity at all. Okay. Number of students who enrolled for skating and swimming only was 10 more than number of students who enrolled for skating and dancing only. Okay. So this is a combo question, wherein you also need the diagram and also need the equations. Let's see. I have swimming 80. I have skating 75. And I have dancing 60. Okay. Number of students who enrolled for skating and swimming only was 10 more than the number of students who enrolled for skating and dancing only. So if this is x plus 10. Okay. Next, we need to know, find the minimum possible number of students who enrolled for at least one of the three activities. So we need to maximize D. We need to maximize D, and I need to minimize this. Okay. If this is X, this is X. Now, the best way to maximize this would be if I were able to maximize this overlap of all three. If I was able to maximize the overlap of all three, then D will instantly get maximized. So let's see how many flags from swimming am I left with? 10 are already gone. So 70 flags here. From 75, 10 are already gone. So 65 here. And from dancing, all 60 flags I'm left with. So I'm left with 195 flags. I'm left with 195 flags, of which I most assuredly know that 100 flags will get used up by people who are in exactly one. So 100 flags are gone to people who use exactly one over enrolled, who do exactly one activity. Activity. So I'm left with 95 flags. For these 95 flags, what is the greatest group that I can have? I can have 31 people. I can have 31 people doing all three activities if I were to distribute flags in groups of 3. Okay. So the greatest possible overlap of all three is going to be 31. Let me fix it. When I fix this as 31, at the same time, what I've also done is I fixed it as 0 and I fixed this as 10. This is done. This is 0. This is 10. Only then I will get 70, 65 in this. So 10, 31. I've got 41 people recorded here. So 34 would come here. Now, this number, let's say this was A. Now these two numbers have to add up to 66. So this is 66 B, 66 minus B, and this has to be B. Or how? No. I will put it differently. 80 minus 41 gone. So this is 39 minus A. And here it will be 29 minus A. And these two numbers have to add up to 66 because people who are doing exactly one activity are 100. So 39 plus 29 will be 60. How much? Let me count. 39 plus 29 minus 2A is equal to 66. So this gives me 2A is equal to 2 or A is equal to 1. So I have one person here. I have 38 people here. I have 28 people here. Let me check the summation. 38 plus 28 gives me 66. 66 plus 34 is 100. All conditions are satisfied. So now minimum possible number of students who enrolled for at least one of the three activities will be given by 80 plus 34 plus 28. The entire circle of swimming is 80. Skating is 24. Designing 28 extra. You add these all up. We will get 142, which should be the answer to this question. Last question. In a class of 20 students, each student was to shake hands with every other student. But half the boys refused to shake hands with 1/3 of the girls. Which of these could be the total number of handshakes? Okay. So total number of handshakes ideally should have been 20C2, which is equal to 20 into 19 by 2 or 190. Now we are told boys plus girls is equal to 20. Additionally, we are told half the boys. If you can calculate half the boys, can you see boys have to be a multiple of 2? Refuse to shake hand with 1/3 of the girls. So girls have to be a multiple of 3. Also, because the boys are a multiple of 2, the total number of kids are a multiple of 2, the girls also have to be a multiple of 2. Or in other words, girls have to necessarily be a multiple of 6. So there are but 3 cases that we have to check. Girls are either 6 or 12 or 18. Correspondingly, boys are either 14 or 8 or 2. So how many handshakes will not take place in the first case? Or how many handshakes will take place in the first case? Is 190 minus 7 into 2. So this will be 176. In the second case, it will be 190 minus 4 into 4, which is 174. And finally, 190 minus 1 into 6, which is 184. So the question, which of these could be the total number of handshakes? Among the 3 options available, just one is available. So option B, that will be the final answer. That will be all for this episode. Hopefully you learned something.